Lesson 7.4 is about the angle-angle similarity postulate. Okay, so the angle-angle similarity postulate is this. If you have two triangles, and you have two angles of one triangle congruent to two angles of another, then the two must be similar. So if I have, say, these two triangles, they're obviously different sizes, but if those two angles are the same, and let's say that these two are the same as each other. So between the two, I have two pairs of congruent angles. Then I can be sure that these two triangles are similar. And that means that, from previous lessons, that similar means they have the same shape but different sizes. So they look, one of them just looks like the other one either blown up or shrunk down. The side lengths are proportional. Okay, so let's just do a little warm-up to see if we look at some pairs of triangles, if the two triangles are similar. So the first criteria is I have to have two pairs of matching angles. So when I look at these two triangles, they look kind of vaguely the same shape, and I see I have one congruent triangle here, but I would need these two to be congruent to each other, and they're not. Because if these third angles were congruent to each other, like on the one on the left, this one would have to be 58 degrees, and this one would have to be 66. So just the one pair of congruent angles does not make for similar triangles. So in this case, the answer is no, they're not similar. Okay, in this next example, I have two triangles, and I'm asked to find if they're congruent. So, I mean, if they're similar. Sorry. So I've got two 50-degree angles, and these two down here aren't the same, but if I look at what the missing lengths would be, or I'm sorry, angle measures, this one would be 70, and this one would be 60. So you know that if two angles of a triangle are congruent to each other, that the third angles also have to be congruent to each other. But anyway, either way we look at it, we have we've got all three of these angles now congruent to the other angles. So definitely, yes, these two are similar triangles. Okay, another example. I'm looking at these two triangles, and I notice that the two triangles formed by these intersecting segments are both right triangles. And because I have these two vertical angles here in the middle congruent to each other, I now have angle-angle congruent to angle-angle. And of course, we know the third angles also are congruent. But all you need to find is two angles in one congruent to two angles in the other, and you have similar triangles. So this one is definitely a yes. Okay, in this next example, we're going to use some proportional reasoning to solve for missing segments x and y. And what we really have here are two triangles, and the question is, are they similar? And if they are, we can use our proportional reasoning. And in fact, they are. If I've got lines parallel here cut by a transversal, then these two corresponding angles would be congruent. Of course, the two on the other side would be. And the little triangle, the one on top, and the big triangle, which is the whole thing, also share that common angle there. So I definitely have by angle-angle postulate, similar triangles. So I'm going to redraw both of them. So this little one on top has, this side is 4, this is y, and we don't know the length across the bottom. Oh, actually it was given. I'm sorry. I needed to know that. So, okay, that's a 6. And then if I draw the big one, it has a 4 plus 2, so it's 6 on the left side. And across the bottom, it's x. And down this side, it's y plus 3 long. It has both the y and the 3. So I'm looking at it as this is 6 long, and this whole side is y plus 3 long. Okay, so what I want to do is come up with my scale factor, so I can solve this with a proportion. So my scale factor, I can look at the sides that I know, that I can see, that are corresponding, and I have a 4 to a 6. So if I go small triangle to big triangle, my scale factor is a 4 to 6, or when I simplify it, 2 to 3. So meaning the little triangle is 2/3 the size of the big triangle. So now using that scale factor to solve for x, I can say, okay, 2 is to 3, like 4 is to 6, as this piece here, 6 is to x. So solving that, I get 2x by cross multiplying here is 18. So x equals 9. Okay, and then again, using my scale factor to find y. 2 is to 3, small triangle is to big triangle, as y is to y plus 3. Okay, so cross multiplying, 3 times y is equal to 2 times the quantity y plus 3. So if I distribute here, 2 times the quantity y plus 3 is 2y plus 6. Subtracting 2y from both sides, y is equal to 6. Okay, for our last example, let's say that we have the sun shining brightly up in the sky, and it's casting a shadow from a tree. And so the tree casts a shadow down onto the ground, and I want to know how tall that tree is. So I go and I stand, and I know that I am, let's say I know that I'm 5 feet tall. So I want to know approximately how tall that tree is. So I stand from the end of the shadow that the tree is making, which is right here. Let's say I stand 12 feet from the farthest point that shadow is cast on the ground. So from here to here, this is 12 feet. Now I want to know what the length of the tree is. So let's call that x, the height of the tree. That's this height right here. So if I'm standing at perpendicular to the ground and the tree is, I've created two similar triangles here. The little triangle I'm in, right here, it shares a common angle with the big triangle that's created by the tree and the shadow with the ground. So I've got 90-degree angles here. So these are similar triangles. So I can use a proportion to estimate the height of the tree. But what I need to know is what's the length of the shadow that the tree is casting. So I'm on the ground. I can do that. So I find the length of this whole shadow is 30. Okay, so now I've got a scale factor here, a 12 to 30 scale factor. And I don't even have to scale it down. Let's just say I want to say shadow on the ground 12. My shadow, okay, that's me, is to the tree shadow of 30, should be the same ratio as my height of 5 to the tree's height of x. So in both numerators I put me, and in both denominators I put the tree. Okay, so this is my shadow to the tree's shadow should be the same relationship as my height, 5 feet, to the tree's height, x. So we can solve that cross-multiplying. Let's do that over to the left here. 12 times x is equal to 30 times 5, or 150. And we get x is 12.5. Okay, so that means I'm 5 feet tall and that the tree is about 12.5 feet tall. Okay, and that's it.